Hi, Ozzy here. In the last few weeks, I've heard some Christian presuppositionalist apologists in hangouts and in online discussions claiming that science is based upon a fallacy known as the fallacy of affirming the consequent. In this video, I want to explain why this claim is mistaken. And if you're not familiar with what this fallacy is, don't worry, I'm going to explain it in detail. Now, before I begin, I want to mention two things. First, uncharacteristically for me, I'm going to be playing 3 brief video clips from 2 recent hangouts where this claim about science was made, so viewers can see and hear for themselves that I'm not setting up a straw man. Links to the original videos with timestamps will be included in the description box of this video, so people can view the originals and assure themselves that nothing's been taken out of context and the views of these gentlemen have not been misrepresented. The other point I want to make is that there are in fact all sorts of difficult, thorny issues when it comes to scientific methodology and the enabling assumptions at the very heart of science. Everything from Hume's problem of how to justify induction, to the nature and types of causation, to how scientific theories are always underdetermined by evidence, to how we demarcate between science and pseudoscience, and much more. I would never want to minimize the seriousness of the issues which logicians, epistemologists, philosophers of science, sociologists of science, and even scientists themselves have brought to light about the nature, the limits, and the assumptions informing the scientific enterprise. There are genuine problems enough that we needn't invoke non-existent ones. So here's the first clip where an apologist, Dustin Segers, describes what he sees as a formal fallacy at the heart of all science, with an example he uses drawn from evolutionary theory. And here he's explaining very candidly why he thinks evolutionary theory is false.
One of the reasons you notice that I gave 3 reasons. Number 1, we believe it doesn't fit with the evidence. Number 2, it contradicts theological standards that we would hold to, namely the Judeo-Christian scriptures. And number 3, and this is one of the biggest problems, is that neo-Darwinian theory is built on, as is any scientific theory, is built upon logical fallacies. Let me give you an example. The most common one that is often ignored is the fallacy of affirming the consequent. And here's how it goes. It's the idea that if evolution is probably true, we would expect to observe homology. Homology is, for instance, a frog has 5 fingers, a radius, a ulna, a scapula, a clavicle. We have 5 fingers, a radius, a ulna, a scapula, humerus, collarbone, just like the frog does. And so they would say, see, common design or common morphology, common structure, similar structure demonstrates and is consistent with, is evidence that is just added to the pile in support of evolutionary theory to show that we came from a common ancestor. And so they would say, okay, therefore evolution is probably true, most likely true, or the greater preponderance of evidence is consistent with one of those being homology, that evolution is the case. What we say is, no, that's a logical fallacy. If P then Q, Q, therefore P. No, that's called affirming the consequent, and that's been long recognized as a fallacy. And atheist, secular, and humanist philosophers of science have long pointed this out. Started with David Hume, and this type of reasoning behind scientific investigation, as far as it's related to cosmology and the origin of life, really took off after the Enlightenment. Before then, scientists didn't engage in this type of thing to the extent that it is now. They didn't engage in these tissue of logical fallacies, but that theory in and of itself can never be true simply because of the fact that it's built on at least 3 logical fallacies: the fallacy of affirming the consequent, the problem of induction, and then the third one is empiricism. Empiricism is fatally flawed. But the first one is the fallacy of affirming the consequent. You cannot determine what's true simply because of mere inductive observations. Just because we see cells changing and adapting to their environments today, and we see organisms doing the same through the process of speciation, natural selection, geographic pressures, artificial selection, whatever that may be, that does not prove that we all came from a rock.
So he mentioned three problems. The problem of how to justify induction without begging the question of induction's reliability, and that is a genuine problem. The issue of empiricism, and I'd agree with him that a pure and strict empiricism is naive and incorrect. And lastly, he mentions the formal fallacy of affirming the consequent. Before going on to the next clip by the next apologist, I just want to call attention to a couple of things. The first is that although he has chosen to illustrate the fallacy of affirming the consequent using an example drawn from evolutionary theory, if he's correct, it would not be limited to evolution, but would be equally applicable to all of science. Indeed, he flatly stated it was a fallacy that infects all of science. The second thing I want to call attention to is a minor mistake he makes. It was probably nothing more than a slip, but strictly speaking, it's a fallacy, and it's a very common one which everyone in the great debate needs to recognize. You'll recall he said that because the theory rests on fallacies, it can never be true. That claim that some proposition or belief or theory or position cannot be true if it's based on a fallacious argument is false. That in and of itself is a fallacy. In fact, it's called the fallacy fallacy. The reason this is a fallacy is because the fact that some position or claim is being argued for on the basis of faulty reasoning, even atrocious reasoning, does not imply that the position or claim is false. One could present a bad argument for anything, even something manifestly true, but one can't infer that the position or claim is false just because someone is relying on a bad argument to support that position or claim. It's very common for people to think that pointing out a fallacy is sufficient to refute the conclusion. Identifying a fallacy in an argument is a reason to reject the argument for a conclusion, not the conclusion itself. Now, I hasten to add here again that this gentleman very likely knows this, merely misspoke when he said that when he said that the fallacies he named, that if those fallacies are present, it means that theory can never be true. He probably meant to say something like, such theories are unwarranted or not rationally justified if the conclusion rests only on fallacious arguments, or something to that effect. All right, on to the next clip, featuring another apologist, Jason Peterson this time, who's an acquaintance of the first, taken from a more recent hangout he hosted on his own channel.
The second problem is that all experiments that are used to attempt to validate a hypothesis or a theory, such as evolution, commits the logical fallacy of asserting the consequent.
Affirming the consequent.
It's also called asserting the consequent too. There's two different ways you can call it. I just say asserting because I just think it sounds better. But asserting the consequent would be the fallacy that science commits. So if you're going to try and say that you can derive some justified true belief from a standpoint of a philosophy that commits that fallacy in order to accept or reject the proposition, then I mean it seems to me that the first principle you're using doesn't really lead you to any sort of what you could call capital T truth, absolute truth. Do you get what I'm saying?
If you don't get what he's saying, he goes on to explain moments later when asked to elaborate.
You were asking me about how science commits asserting the consequent. What I mainly am focusing on in that instance is the way hypotheses are confirmed in science. If your hypothesis is correct, you should observe a certain phenomenon. If P implies Q, that's the first premise. Then the second premise is the phenomenon that I predicted happens. That's Q, right? So then you say, therefore, the hypothesis is confirmed. That's P, and that's the logical structure of asserting the consequent.
Okay.
So both these gentlemen are claiming that science, all science, not just evolutionary theory, rests on a fallacy called affirming the consequent. Okay, so what exactly is this fallacy of affirming the consequent? The fallacy of affirming the consequent is a formal deductive fallacy, which means that the fallacy has to do with the specific form or structure of a deductive argument. That is, the argument does not conform to a legitimate inference rule of deductive logic. The fallacy of affirming the consequent is a common violation of a rule of inference called modus ponens. Now, modus ponens is just a fancy Latin name for an inference rule of logic that you use every single day. And it goes like this. If A is true, then B is true. A is true, therefore B is true. Or, more simply, premise 1, A implies B. Premise 2, A, thus B. And A and B can be any two propositions. So, for instance, premise 1, if it rained, then the street is wet. Premise 2, it rained, therefore the street is wet. Simple enough. So the inference rule modus ponens tells us that B is true if A is true. But it says nothing about what is implied if B is true. So using modus ponens, that inference rule, we can infer B from A, but we can't infer A from B. The following would be incorrect, for instance, a violation of modus ponens. Premise 1, if it rained, then the street is wet. The street is wet, therefore it rained. The fact that the street is wet doesn't imply that it rained. The first premise doesn't tell us what we can infer if the street is wet. It only tells us what we can infer if it rained. There's nothing in the premises that warrant the conclusion. And that's why it's a violation of modus ponens. It's the fallacy of affirming the consequent. By contrast, any argument that follows the correct form, modus ponens, is logically valid. And what that means is that provided that an argument is constructed in that form, if the premises or assumptions are correct, then the conclusion also has to be correct. When an argument is presented in the correct way, in the correct form, conforming to an inference rule, such as modus ponens, there are others, the argument is called valid. It doesn't even matter, though, if the premises are false. Why do I say that? Well, here's an example. All men are bald. Ozzy is a man. Therefore, Ozzy is bald. That's a valid argument. It's valid because the conclusion follows from the premises. The premises entail or imply the conclusion. So this argument is valid. But note that the conclusion, Ozzy is bald, is false. A valid argument can have a false conclusion. The conclusion is true only if the premises are also true. Garbage goes in, garbage comes out. True premises go in, true conclusions come out. That's how validity works. So validity by itself does not ensure truth of a conclusion. And often when people say, well, such and such an argument is valid, or such and such an argument is invalid, they're actually meaning to say that the argument is sound, having not just a valid structure, which conforms to an inference rule of logic, but also has true premises. There's two conditions involved. And this is why in logic we say that a valid inference rule is truth preserving, meaning that if an argument conforms to a certain form, that will guarantee the truth of the conclusion, so long as the premises are true. If the form or structure of the argument is wrong, well, then it doesn't matter if the premises are true. The conclusion might be right or it might be wrong. All bets are off when the structure of the argument is invalid. Which is why we want our arguments to be valid, conforming to truth-preserving inference rules of logic, and also based on true premises. So they will be sound arguments. What you want is a sound argument, not one that is merely valid. So let's return to modus ponens with that in mind. The first premise, if A is true, then B is true, or rather, if A is true, then B is true, is what's called the conditional premise, or the hypothetical conditional premise, because it's an if-then statement. The conditional premise is composed of two parts. The first part, A, is called the antecedent of the conditional. That's the if part of the if-then conditional statement. And the second half, B, is called the consequent of the conditional. That's the then part of the if-then statement. The fallacy of affirming the consequent occurs when one mistakenly tries to affirm that because the consequent is true, the antecedent must be true. If the consequent is true, the antecedent must be true. You're affirming the consequent and making a conclusion that's incorrect. Remember that the conditional premise states that A implies B, and so we can infer B from A. But it tells us nothing at all about what follows from B. So we cannot, may not, infer A from B, even if B is true. That would be fallacious reasoning, a form of argument that does not conform to the truth-preserving inference rule of modus ponens. Now, the argument that the first apologist was objecting to is constructed as follows. If A, evolution is true, then B, we'd expect to observe homologies in the organisms. Second premise. B, we observe homologies in organisms, therefore A, evolution is true. That is, in fact, a case of the fallacy of affirming the consequent. But that's because he's decided what will be the content of the antecedent and what will be the content of the consequent. One could just as easily construct the first premise this way, in reverse order. If A, we observe homology, then B, evolution is true. We observe homology, therefore evolution is true. That's a formally valid argument. There's no formal fallacy when the first premise, the conditional premise, is constructed this way. And this is the way anyone who knows any logic arguing for that conclusion would construct the argument. If that person were trying to offer some sort of deductive proof of the conclusion, that is, a proof of the conclusion. Now, one could challenge the soundness, the veracity of the conditional premise if one wanted to, but then one would have to enter into an argument about the evidence for and against it. But the form of the argument would nevertheless be valid. There is no fallacy here. But when or why would one construct the first premise the way these apologists have suggested? Well, there is in fact a situation when one would and should construct the first premise as they did, when one is doing hypothesis testing. But hypothesis testing doesn't rely on modus ponens. It relies on a different inference rule called modus tollens. And modus tollens is the inference rule that says A implies B, not B, therefore not A. For instance, if there had been an earthquake, my car alarm would have been triggered. My car alarm was not triggered, therefore there was no earthquake. That's a valid form of argument. Modus tollens is the inference rule that we use to describe how we refute or reject a proposition or a hypothesis or a theory. When we devise an experiment, for instance, such as when we say, if hypothesis A is true, we should observe B. When applied to the case of homology and evolution, as the first apologist was describing, it would look like this. If evolution is true, then we'd expect to observe homology in such and such cases. Second premise, we don't observe homology in such and such cases, therefore evolution is false, not true. Modus tollens, therefore, is the formal logical description of the principle of falsification or refutability. It's the logical rule which describes the logic or the reasoning behind falsifiability. So is there a circumstance when it would make sense to structure the conditional premise in the following way, which is what the first apologist did? If A, evolution is true, then B, we'd expect to observe homology in such and such cases. Yeah, absolutely. When one is testing that hypothesis to see if one can falsify it, not prove it. And because we do observe homology, as predicted by evolution, evolution is not falsified. That is, the facts are consistent with the hypothesis. The hypothesis, based on such an argument, stands unrefuted. It's not proven true, of course, but science doesn't proceed by proving things true. It proceeds by eliminating and falsifying incorrect hypotheses, resulting in theory rejection or revision, and any theory which stands unfalsified while having been corroborated by correct predictions, where the conditional premises is ordered correctly, not backwards, as these apologists have uncharitably chosen to do, that warrants our provisional assent until it is falsified. If we didn't observe homology, evolution would be falsified. So what these apologists have done here is order the antecedent and consequent of the conditional premise in the way one would express it if one were applying modus tollens, so as to test or falsify the hypothesis and not argue for the conclusion. But structured that way, if you apply modus tollens, there's no fallacy. But if you apply modus ponens to the conditional premise as they've constructed it and try to generate a deductive proof using modus ponens, that would be a fallacy. But what scientist or logician presenting an argument for a theory would construct the conditional that way, when that's a manifest fallacy? If they were arguing to try to prove the conclusion using modus ponens, they'd construct the hypothetical condition in exactly the reverse way, as I described earlier, and thus there'd be no fallacy of affirming the consequent when properly constructed. Now, these apologists could still, if they wanted to, challenge the veracity of that premise, of course, the soundness of the argument, but there'd be no formal fallacy. The argument is formally valid if you simply reverse the antecedent and consequent in the first premise. Of course, addressing the soundness of a premise in a scientific argument would require that these apologists enter into a discussion about the veracity of the premises, which would be a matter of arguing about the actual evidence. And to do that, one has to have actually studied the relevant science so as to be qualified to evaluate the claims made by the scientists. One can appreciate the temptation to try this end run around all of that by simply mischaracterizing the nature of the enterprise, so that it seems to be committing an obvious fallacy in a bid to discredit not just evolution, but undermine a confidence in all of science, so as to put it on all fours with a faith-based epistemology of gratuitous presuppositions. Now, it's possible that these gentlemen have encountered people who, in arguing these matters, stated their premises sloppily and thus did get the antecedent and consequent reversed when stating their conditional premise, thus committing the fallacy of affirming the consequent. But any fair-minded apologist, schooled in logic, would acknowledge that avoiding the fallacy is trivially easy by restating the conditional premise in reverse order. And when it was stated in the order that the apologist offered, it's so one can apply modus tollens for hypothesis testing, not modus ponens to try and prove it, and therefore not committing the fallacy of affirming the consequent. Okay, that's all for now. I hope this helps a bit, and thank you for watching.